Okay.
And now let's go back and share screen. And before we share screen, let's make sure that the chat is open in case anybody has a question that there. Where I'd like to start, does anybody have anything that they want to look at from any of the homework? Homework 3. One of these days, I will get all of these little things right. Homework 3 is due on the 16th, which is Wednesday. Homework 4 is due on the 18th. Homework 5 is also due on the 18th. Tentatively, I was looking at my calendar, and it looks like exam 1, I believe, is scheduled for the 21st, which is a week from today. Let me real quick go back in Blackboard and make sure I'm not misspeaking. Yeah, exam 1 scheduled for the 21st. I just created a quiz in Blackboard on the Venn diagrams in the union and intersection of sets. I'm going to ask if you could try to please complete that before the end of the day today, tomorrow. It will be open for you folks after class today. I don't think there's any place where you have to upload things, but rather there's places where you have to type your answers that are built right into the quiz. And I'd like to ask you folks on Wednesday to tell me which vehicle you like better for the quiz, the typing your answers in Blackboard or the My Math Lab, and we'll go from there in terms of what we'll do for that test on Monday. If you're more comfortable putting your answers in Blackboard, we can do it as a Blackboard test. If you're more comfortable putting your answers in My Labs, we can do it as a My Labs test. But
so where is that located?
It will be, that quiz will be in content.
Okay.
In content, in Blackboard, there's a folder, tests and quizzes. And you see over here, it shows up for me. It's hidden from you until end of class today. It'll be on Venn diagrams and set operations. All right.
Okay.
On it, and you should be able to just type your answers right in. With this one, I don't think there's anything where you need to upload. So, does anybody want to look at anything from any of the homework problems? You guys are all right?
That, can you hear me, please?
Yes.
Okay. I've not actually do the third one, which is due on the 16th, I think. Because I'm stuck in number 2 and I don't want to move forward. Like, I wanted to do it on Friday and it kept getting you wrong. I said, you know what? I'm stopping. So I started all over again this morning. So I don't know if you don't mind doing that. Just a sample. Let me know where I'm going.
You didn't have to wait till the weekend was over. Do you remember that in Blackboard up here, there's this question help? And in question help, you can click on ask my instructor. And there's a field that you can fill in and type in what you're wondering. And I will get back to you. Okay? So that you can email me if you have a question. There's no need to wait. Also, in one of my other classes, I was talking to somebody over the weekend, and I'm going to, just for a second, intentionally get this wrong. And I think everybody's realized that my math lab gives you 3 tries. Is everybody all right that in addition, after those 3 tries, you can click similar question, and it doesn't give you exactly the same question, but it gives you another question that's almost the same that you can do and still get full credit, okay? So you don't just have 3 chances at every question, you have infinite do-overs. But now let's go to look at this question. First set are the numbers 1 through 16. And if you look at the second set, do you see it's 1, 3, 5? It's the odd numbers through 16. When I see that C with the apostrophe, that means C complement. That means everything that's in the universal set. So the universal set are all of the numbers from 1 through 16. That's not in C. Well, if C contains all of the odd numbers, wouldn't the complement contain all of the even numbers? So that would be, oh, I hate this keyboard, 2, 2, we need to put commas in between, comma, 4, comma, 6, comma, 8, 10, 12, 14, and 16. Oh, Lord. And I did all that typing and it didn't register. 2.
I thought my phone was frozen.
Oh, my heavens.
Ugh.
Go back here again. 2, comma. Anyways, do you get the idea?
Yes.
Yeah.
Do you see what you were missing?
Mm-hmm.
2.
So I have to write out all the odd numbers. Oh, sorry, the
Well, this
even numbers.
contains all the odd numbers, so the complement would be the numbers that are not odd, which would be all of the even numbers.
Yes.
Are they going in this time?
Yeah.
Yeah.
Oh, 6 is in there already, no repeats. And this one, do you see it says use ascending order? You know how we repeatedly said that with a set, order doesn't matter unless they tell you to put them in order? This question is telling me to put them in order. So if I didn't have them in order, it would yell at me. I hope nobody else has a touch screen where you have to switch keyboards each to put the commas in, because that's a pain in the ass. Do I have them all 2, 4, 6, 8, 10, 12, 14, 16? You think we got it right this time? Yes. So the complement of the set is everything that's in the universal set that's not in the original set. And so because my original set was this time the odd numbers, the complement would be the even numbers. Okay?
Okay.
All right. This next one, you see the universal set are all of the numbers. And the set A is the numbers up to 18. So here the complement would be everything larger than 18. So it would include 19.
Not registering again.
Oh, good Lord. Thank you.
Mm-hmm.
So it would include 19, comma, 20, comma, and then you'd have to do the ... because this, the universal set is infinite, so it would be an infinite set in the complement. It's just that because the set is 18 and lower, its complement would be 19 and higher. All right?
Why? The universal set is 1, 2, 3 to infinite, right?
Right.
Oh, then okay.
The complement would be 19. I'm trying, I'm really trying, I'm sorry. 20, 21, but then it would be infinite. So you'd show it by putting that dot, dot, dot.
Okay.
Okay?
Yeah.
All right. Any other questions from the homework that anybody's wondering about?
I've not done enough to do with it.
And again, while you're doing the homework, if you have questions, use that question help, ask my instructor, and
Okay.
I'll get back to you.
Okay.
Let's pick up then, note-wise from where we left off. And we were looking at set operations and Venn diagrams. So let's do one more example of what we had been looking at. Let's say this time our universal set is the set. Did we do one with this end with a one A through G? I don't want to redo the same one.
I don't think so.
Okay, and let's have
We
uppercase.
did up to F.
Okay, then this one's a different one. Let's have A be the set A, C, E, G. Let's have B be the set B, C, D, E. And let's find A union B,
Oh.
A intersect B. Let's find the number of things in A. Let's find the number of things in B. Let's find the number of things in A union B. So first of all, when I look at A union B, taking the union is what? Can anybody remember what we did when we took the union of two sets?
We draw a
What?
Venn diagram.
We could draw a Venn diagram if we wanted to, but we don't necessarily have to. The union was it where they overlapped or was it everything all together?
Everything all together?
Everything all together. So for A union B, we want everything from A, C, E, G, and then we want to add in everything from B, which would be B. Oh wait, C's in there already.
Okay.
D, E's in there already.
E is there.
That one okay. Next, for A intersect B, that's the overlap. Where do A and B overlap? What do they share? What elements do they have in common?
C, E.
That's it.
Beautiful. Now, next, what does it mean when I put the little n in front of the name of a set?
Whole
Many-
number?
It's a whole number. It's the cardinality. It's how many things in the set. So how many things are in set A?
4.
Beautiful. Same way, how many things are in set B?
Also 4.
4. Now I'm gonna, just for a minute, slide this sheet up and pretend we don't have anything else. If there are 4 things in A and 4 things in B, how many things do you think there would be in the combination A union B?
8.
8. But before we put that down, I want to go back and
But
look
don't
at,
they,
go ahead.
don't they double then?
Yeah, that's, if I look at A Union B, how many things are really in there? 1, 2, 3, 4, 5, 6.
But some of them are the same.
But since some of them are the same, it will only be 6. How many things are the same? How many things are in the intersection? 2. And so the author of the textbook goes through and puts this in the formula. They say that the number of things in A union B is equal to the number of things in A plus the number of things in B. But then because nothing counts twice, we're going to subtract the number of things in their intersection. So the number of things in A plus the number of things in B minus the number of things that they have in common. I'm going to just real quick, if memory serves me well, in that homework 3, the first question, if I remember correctly, is something that deals with this idea. Let me see if I'm, oh, no, it isn't. So if I look at this question from the homework, number 38, it says a winter resort took a poll of its 325 people to see which winter activities people enjoyed. The results were as follows. 186 people liked to ski, 185 people liked to snowboard, and 71 people liked to ski and snowboard. How many people in the poll liked to ski or snowboard? I'm going to go back to the notes for just a minute. In terms of word problems like that, one thing that you need to be aware of is when you see the word or behaves like taking the union of the two sets.
Oh,
And when you see the word and behaves like taking the intersection of the two sets. Now, if I go back to that problem, in this problem, we know that the number of people who like to ski is 186. You know the number of people who like to board is 185. Now, if I add those two together, I've got over 370 people. But we know that there were only 325. So we've got to do something. The question asks us for the number of people who like to ski or snowboard. And so that would be like the number of people in ski union snowboard. Are you guys all right if I abbreviate? And by what we just said, it's the number of people who ski plus the number of people who board. Well, we want to make sure that nobody's counted twice. And so we need to subtract the number of people who do both. So far, is everybody following me? Does that make sense?
I guess.
Yeah.
So there are 186 skiers. There are 185 boarders. But there are 71 people who do both. So they're being counted twice. So let's see, 186 plus 185, I think 171?
371.
Thank you. I can add 100 plus 100 would not be 300. I was focusing on the other two digits, minus the 71. So here the correct answer would just be 300. And so while that seems like a far-fetched rule, do you see how with a question like that, subtracting the people that are counted twice is important? Everybody all right with that rule?
Yeah.
He counts twice.
Okay.
If that's all right, I'm going to clear this work. Exit out of this question. And we're going to look at more Venn diagrams today, but what we're going to add are Venn diagrams for 3 sets. With the Venn diagrams for 3 sets, hopefully we will also have time to prove some theorems. So if I look for a Venn diagram for 3 sets, like any Venn diagram, I'm going to start with my universal set. For lack of originality, I'm going to call my first set A, and A will be a loop in there. With 2 sets, if my second set is B, we're going to have the loop for B overlap. Because remember, last week we said we have to leave room for things that are only in A. We have to leave room for things that are only in B. And we have to leave a space for the intersection of the two, things common to both, in addition to complements, things that are outside of both. If I add a third set C, we have to leave the possibility that there are some things in just C, some things common to C with A, some things common to C with B, and some things common to all 3. So when we add a third set, we put the third loop like this, C. I think I've told you before, I think like a little kid. Does anybody else look at this Venn diagram and see Mickey Mouse? So I think, yeah. So I think of these as my Mickey Mouse Venn diagrams. A Venn diagram for 3 sets contains 8 regions. We will find later on that we're going to discuss the regions, and when we do that, we're going to label them with Roman numerals. Most normal, labeling them with Roman numerals, 1 would be here, 2 would be this region, 3 would be over here, 4 would be here, 5 would be smack dab in the middle, then we'd have 6. Down here in the bottom, we'd have 7. And then over here, we'd have 8. So there's sometimes shown with Roman numerals. And I want to give you a heads up on the quiz. On the quiz that I put together, I wanted to ask you guys to draw a Venn diagram, and I wanted to have you upload your picture, but I was afraid that I didn't want anybody to get upset on a quiz if they couldn't get the picture uploaded. And so what I did instead was I drew a general Venn diagram and I labeled the regions and just asked you to tell me what's in each region. So hopefully that works for everybody. And you're going to just type in region 1 and what's in there, region 2 and what's in there, and so on. But let's go through and let's look at these 8 regions. And if I look at region 1, is everybody all right? Region 1 would be the elements only in A. What would you tell me about region 2? It would be common to A and B, but not C.
Yes.
What would be in region 3?
Just B.
Elements only in B. What would be in regions 4, IV? And hey, folks, when you're doing these things on your own, if you're more comfortable with regular numbers instead of Roman numerals, that's fine with me. But you're going to find in my math lab with these ones, they use the Roman numerals. So region 4, IV is over here. What would that be?
A and C.
But not B.
Common to A and C, but not B. What would be in region 5?
Common to
All
A,
three.
B, and C.
So can I just write common to all? Is everybody okay with that?
Mhm.
What's in region 6? Over here.
B and C.
Common to B and C, but not A. Hey, they're common to B and C, but not A. Can I look at that symbolically as B intersects C? And outside of A, wouldn't that be intersect A complement? Outside of A. That's the way we'd write that statement symbolically. What about region, oops, it would help if I wrote what I was thinking. What about region 7?
That's just C.
Just C, only in C. And how about region 8?
The universal set.
But not the entire universal set, right? The universal set outside of the other 3?
Yeah.
And so let's look at an example of filling in a Venn diagram like this with elements. But before we do that, we're going to stick to that rule that we fill in starting with the center. And we work our way out. And there's probably room at the bottom of this page for another example, but because it's virtual paper, I'm not really being environmentally incorrect. I'm going to start the next example on a separate page if everybody's ready. Y'all ready?
Minute.
For my example, let's have our universal set be the numbers 1 through 12. let's have set A be the evens, 2, 4, 6, 8, 10, 12. Let's have set B be the multiples of 3, 3, 6, 9, 12. And let's have C be some of those middle numbers, 4, 5, 6, 7. And let's start by drawing a Venn diagram.
Wait, does 1 also go in C or?
No, C is just 4, 5, 6, 7.
Okay.
Now, first of all, let's look at this question. We have our universal set, and we have 1, 2, 3 other sets. Is everybody all right? The fact that there's A, B, and C tells me this is going to be a 3-looper, one of my Mickey Mouse Venn diagrams. I'm going to label my universal set. I'm going to label my loops A, B, and C. You don't necessarily, if you're drawing one by hand, have to put yours in the same order. But what's important is that you label the loops so that I know that the right elements are in the right sets. Instead, to fill in a Venn diagram, we're going to start in the middle, which would be here. So we're going to start with what's common to both, all 3 of them. And so let's see. A is 2, 4, 6, 8, 10, 12. B is 3, 6, 9, 12. C is 4, 5, 6, 7. Is there anything that's shared by all 3 sets?
6.
6.
So we'll put 6 in there. And when we put 6 in there, does everybody see from where it's placed? 6 is already in my universal set.
Mm-hmm.
6 is in loop A, 6 is in loop B, 6 is in loop C. That's the only time I'm putting C in. Now, as I work my way out, I try to fill in these 3 smaller overlapping regions. So if I start here, this would be what A shares with B. A and B share 6, but it's in there already. Do they share 12?
12.
Then I want to look over here where B and C overlap. B and C share 6. It's in there already. Do they share anything else?
Nope.
No.
Mm-mm.
So we'll leave that empty. And then I want to see over here, what does A share with C?
4.
4.
4 and 6.
4 and 6, but again, 6 is in there already, so there's no need to repeat. Now, we'll fill in the rest of our loops. A has 4, 6, 12. Is there anything else that goes in A? Yeah, I think it's 2, 4 is in there, 6
It's already there.
8 we need to add, and 10. Let's finish filling in B. B has 3
3,
9.
9.
9.
and 12's in there already. Beautiful. And now for the rest of C. C's got 4. We need to add,
5 and 7.
5. 5 and 7.
and C now contains 4, 5, 6, 7. I'm not sure if I'm done yet. I have to finish the universal set. Universal set contains 1. I don't think we've put that in there yet. 2 is in there, 3 is in there, 4 is, 5 is, 6 is, 7 is, 8 is, 9 is, 10 is, I don't think 11 is.
Where is 11? So that's the universal set.
And so do you see how if you start with the overlap and work your way out, you're going to keep yourself from making careless mistakes by putting something in that diagram more than once. Now let's find a few sets. To start with, let's find a complement. What's outside of A?
3,
3, 9.
3, 5, 7, 9. Well, wait.
3, 9, 5, 7. Anything else?
1 and 11.
1 and 11. Beautiful. What's in A intersect B?
12. 12 and 6.
12 and 6. The intersection is where those two loops overlap, including to what's common to all three. So what if I take A intersect B in parentheses, union C?
That's just 6, right?
Oh, 4.
We're taking the union with 6. A intersect B is the 12 and 6. So I need
4.
and now I want
C.
to add the rest of C. So don't I have to add
5, 7.
5, 4?
Oh, okay.
And when I take the union, I'm combining them and putting them together. What if I take a complement intersect C? What does outside of A have in common with C?
4.
Let's look at 4. Is 4 inside of A or outside of A?
That would be inside of A.
It would be inside of A, and we only want what's outside of A. So what's outside of A, but inside
In
of
C.
5.
5,
And 7.
5, and 7. And can everybody see that from the diagram? We're looking outside of the loop for A, but inside the loop for C. If it's challenging getting the more involved ones like that from the diagram, go to the rosters. Make a roster for A complement, which we did already. Make a roster for C, which we did already, and compare these two sets. What's outside of A got in common with inside of C. And comparing the rosters, does everybody see out A complement and C both share just 5 and 7? Now let's look at, let's look at a real challenging one. Let's
So
look.
Tom, I have a question.
Sure.
Complement is just what's outside of what it is.
Complement is what's outside the set, but inside the
Okay.
universe. Okay?
Okay.
So now let's look at A union B complement intersect C. Did you folks want to try to get this from the Venn diagram? Or did you want to try to get it from the sets? Or should we do both?
Like that.
Let's start, I guess let's start by looking at the sets. As I look at this, the first thing I need to figure out is what's A union B. When I put A and B together, I have 2, 4, 6, 8, 10, 12, all of A, and add the rest, what else is also in B, so I'm adding 3.
3, 9.
Now I'm going to see if I can play with my pen and not mess up too bad. A union B, if I were looking at the Venn diagram, is what's in this red kind of sideways snowman part, what's in Mickey's ears. Yes?
Okay.
So
Now,
it's just 5 and 7 again.
eventually, let's go through one step at a time though, okay? So when
Okay.
I look for A union B complement, I want the complement of that. So I want to exclude that. And excluding that, wouldn't that give me 1, 5, 7, and 11?
Okay.
So that's this part. Or what's outside the ears. C, I'm going to rewrite. C was 4, 5, 6, 7. So when I take the intersection of these two sets, what do they have in common? 5,
5, 7.
5, and 7. Or going back to my color coding, I took A union B. A union B was this red part. And then when I look for the complement, it's what's outside of the red. And so when I look for the outside of the red intersect C, I'm saying what's outside of the red also in C. And so do you see how you can see it by looking at the picture? We're looking for outside A combined with B and inside C. Yes, no, maybe.
Yeah.
Yes.
Okay. Let's see what time we got. All right, we're not going to prove theorems today because we can't prove theorems in, is it really 48? Do we really just have 2 minutes left?
Wow.
Yeah.
Okay, so give me a minute. Let's look and see what's going on with this homework. The homework that's due on Wednesday is just 2 sets. The homework that's due on Friday is 3 sets. And surveys, we might push that back a little bit and revisit test, what the date for the test being Monday, depending on how far we get on Wednesday, all right? But for
Okay.
now, if you just focus on the assignment that's due the 12th, you should be fine. You should be able to do the first couple ones in the assignment that's due the 18th, but don't stress if you get to the ones with all the Roman numerals in them. We'll be looking at those on Wednesday, all right?
Okay.
Okay.
And please, the questions that are on the quiz that needs to be completed by midnight tomorrow are similar to the questions in this homework.
مع المهدئ لما جاي يمكن اقعد اشوف لي الدوايات راح اجيب اياها تعالوا بعد ما نكمل.
Is that a question or somebody got
يلا
that
يلا
side
حبيبي يلا
conversation?
يلا
I'm guessing a side conversation.
يلا هلا انا ادري بك انت ما تقرا انت قاعد تلعب لي بالهذا
Is
يلا.
everybody okay? Any questions on what we did today? We'll start
No.
with 3-loop Venn diagram and try to prove a theorem on Wednesday. If you have any questions, ask. Go ahead, Adam.
Just for the quiz that's today and tomorrow, how many questions is it?
I think there are either 5 or 6.
Okay.
Okay?
All right, that's doable.
Yeah, it is. You've got 20 minutes for it. If time is an issue for anybody, let me know. All right?
Okay.
If anybody has technical problems in the middle of it, let me know. And we can, revisit things. So, and then afterwards, please let me know if you're more comfortable doing a test in Blackboard or in my labs. All right?
Okay.
Thank you.
Okay, have a great day, guys.
You too.
Thank
Thanks, you too.
Okay,
Bye.
bye-bye. And if anybody came in after attendance, let me know.
I came in after attendance.
Okay, Lauren, I'm glad I threw that sentence out there. If I don't throw that sentence out there, are you all right? It's kind of sort of it's your responsibility to let me know, because after I take attendance, I don't go back and look again,
Right.
especially because it's hard staring. I wish you guys were real people in a room and not little names in a box. So, okay, thanks for letting me know, Lauren.
Yes, thank you.
Okay, anybody else have anything?
Yeah, I sent a test to your phone. I took a picture of something I was working on. I don't know.
You sent it to my email?
No, your phone. I sent it as a message to your phone this morning. I was working on something.
Oh, a phone message. Okay, I did not. I usually check my phone at the end of the day. What did you send me? And that's a landline phone, so it won't receive text.
I'm sorry?
That's a landline phone, so it will not receive text.
Oh, really?
Before we go on, I'm going to stop recording.
Okay.